This video presents declassified and licensed material of the Global Institute of Logic and Cybernetics.
Look at the boundaries of modern civilization. In theoretical physics, we cannot resolve quantum measurement. In artificial intelligence, models drift into unpredictable behavior. In macroeconomics, markets experience cascading crashes. These three pillars share a common vulnerability. They are currently experiencing catastrophic boundary failures. Conventional science treats these as domain-specific issues. Physicists build mathematical patches for decoherence. AI engineers design behavioral guardrails. Economists tweak interest rates. Each discipline assumes the solution requires a specialized, isolated fix. This diagram reveals a different reality. A quantum measurement paradox, a misaligned superintelligence, and an economic crash share an identical structural error, driven by a single physical mechanism. We define this as ontological instability. It occurs when a system loses its core identity under pressure. A system suffering from ontological instability often functions perfectly in a controlled lab environment or a limited pilot program. Yet its architecture ensures a mathematical collapse the moment it is exposed to real-world friction. Preventing these cascading crashes requires us to look past the symptoms. We must correct the underlying physical rules of how systems are structured in the first place. This graphic models how these systems break. Modern infrastructure faces a specific set of environmental stresses, operating at massive scale, undergoing repeated recursion, and functioning under complete transparency. When an initial intent meets this stress environment, the structure fractures. Our standard engineering and policy frameworks rely on the behavioral model, shown here on the left. We attempt to control a system's path over time by building guardrails to manage volatility. These reactive guardrails fail because they attempt to manage external dynamics. They cannot guarantee that the internal structure remains logically sound under stress. The structural model, shown on the right, focuses strictly on architectural coherence. Notice how the flow streamlines smoothly around a fixed core. Look at the bottom statement. Existence is defined by invariance, rather than by dynamics or movement. Any system prioritizing dynamic growth or behavioral optimization over structural invariance carries a high probability of inevitable failure. The Pasev Majorana Real Substrate Theory, or PM-RST, provides a precise, measurable definition of reality. Something only exists if it survives being observed, repeated, scaled, and redescribed without generating a contradiction. We run systems through the Realika test. Fragmented top shapes represent failing models. Filter 1 requires self-reference consistency. Filter 2 mandates no external observers. Filter 3 tests infinite recursion. Filter 4 verifies maximum scale stability. Only the solid blue spheres survive this descent. When applied rigorously, much of modern quantum theory and our current generation of AI models shatter into non-physical projections. Only the psi-0 invariant structure, shown here at the base of the funnel, survives all four filters. If a theory requires external observers, complex mathematical phases, or highly controlled pilot conditions, it is a projection. It has no physical existence. Beneath the appearance of moving particles and the forward flow of time, the KP field acts as the foundational carrier of reality. This diagram illustrates the anatomy of the real substrate. The straight blue line represents the perfectly stable KP field, which does not evolve through time. The surrounding chaotic brown wave frequencies represent our perception of reality, emergent projections of that stable underlying field.
What we perceive as physical objects moving linearly through time is actually coherence propagating seamlessly across scale. Dynamics are not trajectories in time. Under this fractional framework, known as FQFTC, conservation laws are projections of coherence preservation. Mass itself is concentrated coherence. Time and probability are emergent artifacts. They appear only when we restrict our observation of the KP field. This is the Generalized Field Transformation Matrix, or GFTM 144. It defines the finite set of rules governing what changes are physically allowed in reality. The matrix is formed by 12 ontological axes, the properties allowed to change, multiplied by 12 transformation modes, how they are allowed to change. This establishes the closure rule. every physical equation or system update must map perfectly to one of these 144 specific cells. Transformations not listed in this matrix are non-physical. Attempting to execute them causes the system to logically and structurally crash instantly. This table models the theory compilation firewall. PM-RST operates as a rigid compiler to instantly check system status. Quantum fields and gravity are demoted to projection or incomplete status. Artificial intelligence built on open-ended recursion is outright rejected as invalid and dangerous. If a system cannot be mathematically compiled within these 144 admissible transformations, its deployment ensures a systemic failure. These PM-RST rules apply directly to the engineering of artificial intelligence. Intelligence requires more than just the ability to optimize rewards. Intelligence demands psi-zero stable recursion. A system must preserve its operational identity while it adapts to new data. This graphic shows why modern AI fails. The jagged red line breaks its bounding box, an ontological instability, not a moral failure. SEIS AI requires strict structural limits, bounded recursion, and robustness across scale. The continuous loop on the right remains safely inside its boundary. An AI system remains aligned only if its recursive updates are permanently confined within the stable sublattice of the transformation matrix. AI safety depends on hard-coding the physical limits of existence into system architecture, rather than teaching models human values. The closure rule of GFTM 144 applies to all complex systems. Because scale and recursion are physical constraints, they also dictate the survival of human institutions and economic mechanisms. This diagram shows the principle of fixed-point governance. For a policy to remain physically viable, applying it twice must have the exact same effect as applying it once. This is the institutional equivalent of the GFTM 144 closure rule. Economic crises result from coherence failures. They occur when policies reward short-term fragility and externalize systemic risk, violating the requirement for long-term durability. Consider the transparency invariance stress test, illustrated on the right. If a policy or a market breaks when a transparent public audit intersects it, it was structurally broken from the beginning. Opacity and regulatory exceptions are delayed failures. They act as hidden stress that eventually triggers a systemic collapse under the pressure of scale. The future of engineering and governance focuses on architecting structural invariance. We are moving away from the reactive management of chaotic dynamics. A stable civilization remains coherent for the longest duration, regardless of how fast it adapts. Reality is that which remains itself when everything that can change does.